Good morning, students. Today is my third lecture regarding colligative properties. So now I am going to start my last colligative property, that is osmotic pressure. Osmotic pressure is related to osmosis. Osmosis is a biological process in which the flow of solvent occurs from dilute solution to concentrated solution, or we can say solvent into solution site through semi-permeable membranes. That is the spontaneous flow of solvent from higher concentration to lower concentration through semi-permeable membranes SPM called osmosis. Suppose if we take one side pure solvent and the other side we take solution and separate through SPM, semi-permeable membranes, then automatically the flow of solvent occurs from pure solvent to solution side. You can also take a left side dilute solution. And right side you can take concentrated solution. So you can say that the flow of solvent from dilute solution into concentrated solution through SPM, this process is called what? Osmosis. In the definition of osmosis, first we have to understand semi-permeable membranes. A membranes which allows solvent not solute to pass through it is called semi-permeable membranes SPM. These membranes in chemistry generally made from cupric ferrocyanide. It is a complex compound, or you can take diluted calcium phosphate. The character of membranes is that through these membranes only passes of solvent, not solute particles. The clumping of water up a tall tree from this soil is an example of what? Osmosis. You can say the climbing of water up a tall tree from the soil is an example of osmosis. The second most important example is that swelling of dry resin when placed in water. Such two examples are very good for what our osmosis process. Osmosis is just like diffusion, but there is a large difference between osmosis and diffusion. The difference of osmosis and diffusion can be understood with the help of following. That is, left side we take osmosis and right side diffusion. The first difference between osmosis and diffusion is that in osmosis SPM required, but diffusion no requirement of SPM. Second one, it applied to this solution. Which type of solution? Liquid solution. In diffusion we take liquid solution or gaseous solution. The next difference is that it can be stopped or reversed, but diffusion cannot be reversed or stopped. Now the next difference is that it takes place from lower concentration to higher concentration, but it takes place from higher to lower concentration. The last difference is that in this process only flow of solvent molecule, but in this process solvent as well as solute particle moves. But the condition is that in diffusion the movement takes place from higher concentration to lower concentration. So in last we have to understand osmotic pressure. The minimum pressure which must be applied from solution in order to prevent the flow of solvent into it through SPM is called osmotic pressure. This pressure generally represented by pi. So in other words we can say the minimum pressure which must be applied from solution side to just stop the osmosis process is called what? Osmotic pressure. That is the minimum pressure which must be applied from solution in order to prevent the flow of solvent into it through SPM is called osmotic pressure. Osmotic pressure generally represented by what? Pi. Suppose we take this type of instrument. This is said to be SPM. Left side we take pure solvent and right side we take solution. Then through natural process the pure solvent flow into solution side through semi-permeable membranes. So if we applying pressure in solution side, that is pi, to just stop this osmosis process is called what? Osmotic pressure, which is generally represented by. So in next heading I am discussing about laws of osmotic pressure. Laws of osmotic pressure. In our gaseous chapters, there are so many parameters are available like pressure, temperature, volume and number of moles. So according to osmotic pressure, the first law is that the osmotic pressure is inversely proportional to volume. If T and N are constant, this law is similar to Waller's law. The second law the osmotic pressure is directly proportional to absolute temperature. If V and N are constant, this law is similar to Galus's law. And the third last one, we can say our osmotic pressure is directly proportional to number of moles. If V and T are constant, this law is similar to Avogadro law. So all above laws when combined to each other, we can write what? Pi proportional to Tn by V. Again we can write pi V proportional to Tn. If we remove proportionality constant, use Rtn. We can write after rearrangement. This equation is similar to gaseous equation known as what? Ideal gas equation. From equation first, again we can write what? From equation first, again we can write pi is equal to N by V RT. N by V is nothing, it is said to be what? Molar concentration. So again we can write pi is equal to CRT. This is our equation second, where C is equal to molar concentration. So if C, T are given, R is constant, known as what? Osmotic pressure constant, which is also known as gas constant. Then we can find out the value of what? Osmotic pressure. Generally, the value of R become taken 0.082 liter atm per mole per Kelvin, or you can take kilo Pascal liter per Kelvin per mole. So always remember the value of what? From equation first, again we can rewrite what? Pi V weight m dash into R into T. Pi is equal to W by m dash into V into R into T. This is equation number 3. From equation 3, it is clear if all terms in right side are given except m dash. What is m dash? Molecular mass of solute. Then we can predict the osmotic pressure. But if osmotic pressure is given and other terms are given, then we can predict molecular mass of solute. But the condition is that our solute become non-volatile and non-electrolyte in nature. If solute or electrolyte means dissociate in solution, then molar mass obtained through this colligative property, again we can say, gives the lesser value compared to ideal. If solute associate in solution, then molar mass obtained through this colligative properties become greater compared to ideal value, where W small mass of solute, R is equal to osmotic pressure constant, which is also known as gas constant. T is equal to always absolute temperature. V is equal to 1 and pi is equal to osmotic pressure. From equation 3, again we can say this term is called what? Number of moles of solute. So this property directly proportional to number of moles of solute, hence again said to be what? Colligative property. That is pi proportional to number of moles of solute. Therefore, it is also said to be a colligative property, because number of moles depends upon the number of what? One point always remember, the osmotic pressure method is preferred for the determination of molar mass of macromolecules compared to other colligative properties, because the magnitude of osmotic pressure is much larger than the magnitude of other colligative properties for any given solution. large magnitude of osmotic pressure permit precise measurement. Means other colligative properties always obtained in the form of difference, but osmotic pressure gives our absolute result. So for macromolecules, this method is very useful for the determination of molar masses. Okay. The last heading is isotonic solutions, hypertonic solutions and hypotonic solutions. Suppose two solutions are given, solution first and solution second. The osmotic pressure of solution 1 is pi 1 and the second become pi 2. Under similar conditions at constant temperature, if pi 1 is equal to pi 2, then we can say solutions are isotonic to each other. Isotonic means what? Similar. Solution become isotonic. If pi 1 greater than pi 2, then we can say solution first is hypertonic solution with respect to solution B, or we can say solution B is hypotonic with respect to solution A. If pi 1 greater than pi 2, then solution first is hypertonic with respect to solution second, or we can say the solution second is hypotonic with respect to solution first. Our last heading is reverse osmosis. RO. All modern water purifier is based upon the mechanism known as reverse osmosis. The following pattern of diagram is possible in reverse osmosis. That is, this is piston, this one is water outlet, this is called SPM. The left portion we take suppose solution and right portion we take pure solvent. So in solution side, we applied a pressure P, which is greater compared to osmotic pressure. Then flow of solvent from solution to pure solvent side occur through SPM. This process is known as what? Reverse osmosis. We can say what? If P is greater than osmotic pressure, then the osmosis process become reverse, known as reverse osmosis. The desalination of seawater is based upon RO system. The desalination of seawater is based upon reverse osmosis. Okay, so in next class I will teach you our last topic in solution, that is vent half factor and the determination of correct molar mass of solute when electrolytes are given in the solution. Thank you.